Picture this. You're standing in a grocery store aisle, staring at two seemingly identical cans of soup. One is slightly cheaper, but the other has a label you vaguely recognize. Which one do you choose? This seemingly simple scenario, repeated countless times a day in different forms, unveils the incredibly complex machinery whirring away inside your skull, the neural and cognitive processes of decision-making. It's not a single isolated event, but rather an intricate dance, a symphony of different brain regions, chemical messengers and cognitive biases all playing their parts. We're not talking about a cold, calculating computer spitting out the optimal choice. We're talking about a messy, beautiful, and often irrational human process. Let's delve into this fascinating world, moving beyond the simplistic notion of rational choice and exploring the reality of how your brain actually makes decisions, from the automatic reflexes that keep you alive to the conscious deliberations that shape your future. We can think of decision-making as existing on a spectrum. At one end, we have reflexive, automatic decisions. Imagine touching a hot stove. You don't think about pulling your hand away. You just do it. This is a lightning-fast, unconscious response, driven primarily by the spinal cord and brainstem. It's about survival, pure and simple. The brain prioritizes speed over deliberation. No time for a pros and cons list when your hand is on fire. At the other end of the spectrum, we have deliberate, controlled decisions. Think about choosing a college, accepting a job offer, or deciding whether to get married. These are slow, conscious processes involving careful consideration of options, weighing potential outcomes and planning for the future. These are the decisions that define our lives, shaped by our values, goals, and aspirations. They're anything but automatic. And of course, most of our decisions fall somewhere in between these two extremes, a blend of automatic and controlled processes. We navigate this spectrum constantly, sometimes relying on gut feelings, other times meticulously analyzing every detail. Now let's meet the key players in this neural drama. The star of the show, in many ways, is the prefrontal cortex, the most recently evolved part of the human brain, located right behind your forehead. Think of it as the executive control center, responsible for planning, working memory, and, crucially, inhibiting impulses. This is where you weigh the long-term consequences of your actions, resist temptations, and make choices aligned with your goals. But the prefrontal cortex isn't a monolith. It has different sub-regions, each with its own specialized role. The dorsolateral prefrontal cortex, for example, is heavily involved in cognitive control, keeping your goals in mind, suppressing distractions, and making plans. It's the part of your brain that helps you stick to your diet, even when that chocolate cake is staring you in the face. It's about deliberate, calculated choices. On the other hand, the ventromedial prefrontal cortex is more connected to emotional processing. It helps you assign value to different options, taking into account your feelings and past experiences. It's the part of the brain that might make you choose the slightly more expensive soup because the label reminds you of your grandmother's cooking. It's about decisions influenced by emotions, memories, and personal values. But the prefrontal cortex doesn't work in isolation. Deep within the brain lies the limbic system, the ancient emotional core. Key players here include the amygdala, which processes fear and other strong emotions, and the nucleus accumbens, a crucial part of the brain's reward circuitry. The limbic system exerts a powerful influence on our decisions, often without us even realizing it. Think about it. Have you ever made a decision based on fear, excitement, or even just a vague feeling of unease? That's your limbic system. At work, consider the famous Iowa gambling task, a classic experiment in neuroscience. Participants are presented with 4 decks of cards. Some decks offer high rewards, but also carry high risks, while others offer smaller but more consistent gains. People with damage to the ventromedial prefrontal cortex often struggle with this task, repeatedly choosing the high-risk decks, even when they consistently lose money. They understand the rules of the game intellectually, but they can't seem to learn from their mistakes or anticipate the negative consequences. This highlights the crucial role of the ventromedial prefrontal cortex in integrating emotional information into decision-making. It's not just about cold, hard logic. It's about gut feelings and learning from experience. Then there are the basal ganglia, a group of structures deep within the brain involved in habit formation, motor control, and importantly, decision-making based on past rewards. Think about learning to ride a bike. At first, it requires intense concentration and conscious effort, but over time it becomes automatic, almost effortless. That's your basal ganglia at work, learning and storing the sequence of movements required for successful cycling. The same principle applies to many of our everyday decisions. We often choose options that have been rewarding in the past, even if we're not consciously aware of it. This can be incredibly efficient, but it can also lead to biases and suboptimal choices. Other brain areas also play a crucial role. The parietal cortex integrates sensory information, helping you to perceive the world around you and make decisions based on that information. The anterior cingulate cortex monitors conflicts between different options and helps detect errors. It's the part of your brain that screams, "Oops," when you realize you've made a mistake. So how do all these different brain areas work together to produce a decision? It's not a simple linear process where one area passes the baton to the next. Instead, it's more like a complex dynamic network, with different areas constantly interacting and competing with each other. One influential model of decision-making is the drift diffusion model. Imagine a scale, with one side representing option A and the other side representing option B. As you gather information, evidence accumulates on one side or the other. When the evidence reaches a certain threshold, a decision is made. This model captures the idea that decision-making is a process of accumulating evidence over time, and it can explain both the speed and accuracy of our choices. It suggests that decisions aren't instantaneous events, but rather the result of a gradual buildup of information. Another perspective is the competing accumulator model. This suggests that different options literally compete with each other within the brain. Neural activity representing each option increases over time, and the option that reaches a threshold of activation first wins and is selected. Think of it like a horse race, with different neural pathways representing different horses, all vying for the finish line. But what about the classic rational choice model, the idea that we always choose the option that maximizes our expected utility? This model, often used in economics, assumes that we have perfect information, unlimited cognitive resources, and stable preferences. But anyone who's ever struggled to make a decision knows that this is a far cry from reality. We're constantly bombarded with information, our cognitive resources are limited, and our preferences are often fluid and context-dependent. We're susceptible to all sorts of cognitive biases, mental shortcuts that can lead us astray. For instance, consider the framing effect. The way information is presented can dramatically influence our choices, even if the underlying options are identical. Would you rather have surgery with a 90% survival rate or a 10% mortality rate? It's the same thing, but the framing makes a huge difference. This highlights how easily our rational processes can be hijacked by subtle influences. Or take loss aversion. We tend to feel the pain of a loss more strongly than the pleasure of an equivalent gain. This can lead us to make irrational decisions, like holding onto a losing stock for too long, hoping to avoid the pain of admitting defeat. It's a powerful demonstration of how emotions can override logic. And what about intuition? That gut feeling that tells you something is right or wrong, even if you can't explain why. Intuition can be incredibly valuable, especially in situations where you have a lot of experience. Experts in various fields, from chess masters to firefighters, often rely on intuition to make quick, accurate decisions. Their brains have learned to recognize patterns and subtle cues that others might miss. But intuition can also be misleading. Our gut feelings can be influenced by biases, stereotypes, and irrelevant information. It's crucial to be aware of both, the strengths and limitations of intuition, and to balance it with careful, deliberate thinking. It's not about choosing one over the other, but about using both intuition and reason in a complementary way. So where does all this leave us? We've seen that decision-making is a complex, multifaceted process involving multiple brain regions, different levels of processing, and a constant interplay between reason and emotion. It's a journey, not a destination, a constant negotiation between different parts of ourselves. There's no single decision-making center in the brain. Instead, it's a distributed network, a symphony of different brain regions working together. The prefrontal cortex plays a crucial role in deliberate, controlled decisions, but it's heavily influenced by the limbic system's emotional input. The basal ganglia contribute to habit-based choices, while other areas integrate sensory information and monitor for conflicts. The classical rational model is a useful starting point, but it's far from the whole story. Our decisions are shaped by emotions, biases, and heuristics, often without us even realizing it. We're not perfectly rational beings, we're human, and that's okay. Understanding the neural and cognitive mechanisms of decision-making is not just an academic exercise. It has profound implications for our everyday lives. It can help us to make better choices, to resist impulsive behaviors, and to understand our own biases. Think about the implications for advertising and marketing. By understanding how the brain makes decisions, companies can design more effective campaigns that tap into our emotions and subconscious biases, or consider the implications for public policy. By understanding the factors that influence our choices, policymakers can design interventions that nudge us towards healthier, more sustainable behaviors. But perhaps the most important implication is for our own self-awareness. By understanding the processes that drive our decisions, we can gain greater control over our lives. We can learn to recognize our own biases, to regulate our emotions, and to make choices that are more aligned with our long-term goals. We can become more mindful of the forces that shape our choices and more intentional in the way we live our lives. It's about empowering ourselves to become more conscious, more deliberate, and ultimately more free. It's about taking ownership of the intricate machinery within our skulls and learning to use it to its full potential. It's a lifelong process, a constant journey of self-discovery, but the rewards are immeasurable. The ability to make informed, conscious decisions is, after all, what allows us to shape our own destinies, and that ultimately is what makes us human.